Hello and welcome to Inscribed Angles. Inscribed angle is an angle where the vertex of the angle is on the edge of the circle. So the first conjecture is that if an angle is inscribed, then the measure of the arc is twice the measure of the angle. So whatever this angle is, this arc is double that. With a central angle, we know that it will be equal to it, but an inscribed angle all the way back makes this double. So if we have something like this, and we know that this is a 140-degree arc, then that makes the angle that's inscribed here to be 70 degrees, just half as much. If we know the inscribed angle is 34, then this arc would need to be 68. Pretty straightforward. Okay? The next thing is that if two inscribed angles of a circle intercept the same arc, then those angles are equal. So let's suppose we have an arc here, and we've got one inscribed angle here that's x, and one inscribed angle here that's y. Well, then we know this would have to be 2x to be double the x1, and it would also have to be 2y to double the y1. So 2x would have to equal 2y, which means x would have to equal y, which means these angles would have to be the same. Anytime you've got two angles matching with the same arc, those angles have to be the same. A couple examples here that are already kind of worked out here for us. To find the measure of angle 1 and angle 2, okay, you see here angle 1, the inscribed angle is here. And so if this is 116, that has to be 58, half as much. And for angle 2, that's an inscribed angle, this is 116. So again, 58. So and 1 and 2 are both 58. In something like this, we know that this is some inscribed angle, x plus 82, and that's equal to, this would be 2 times that amount, and this would also be 2 times this amount, which means these angles have to be equal. So x plus 82 would have to equal 3x, and x would have to equal 41. The third conjecture is that if an inscribed angle intercepts a semicircle, the angle is a right angle, which should make sense because a semicircle is 180, so we know that half of that would have to be 90. So if you had something like this, and here's 3x making an angle with a semicircle, well then that 3x would have to be 90, and then we could get x is 30. What if we have something like this? We've got 5x, so then 5x would be 90, x is 18, we know that has to be half of the 180. For something like this, they give us x over here, they tell us this one's 52. So now here's a semicircle, 180, so from that we can figure out that this has to be 90 because that has to be half as much. And then with using the two triangles, or the two angles in the triangle, subtracting this one has to be 38. Now we've got an inscribed angle from 38, so this one has to be double the 38, which is 76. Lastly, if a quadrilateral is inscribed in a circle, then the opposite angles are supplementary. So let's say we've got a quadrilateral here with angles 1, 2, 3, and 4. We'll call this one x and this one y. Well then, this one would have to be 2x, and this would have to be 2y. And we know together 2x plus 2y makes 360, right? Well, if we divide everything by 2, then x plus y has to be 180. So no matter what x and y are, they have to add up to be 180. They have to be supplementary. And if those are 180, then these also have to be 180 because the total has to be 360. Okay, last example here. If this angle is 92 and IFG is 84, so if we're given these two, find some other stuff. Well, then this has to be supplementary, so we can subtract. This has to be 88. Then we can subtract here. This has to be 96. So we've got 96 and 88. That's inscribed angles. Half of the arc. Have a great day.